Hi everyone. We know that Docker can manage access using network rules. In this video, we will talk about Bridge Network Driver, which is one of the Docker network drivers. It is also easy to understand and implement for Docker beginners or developers. Bridge Network Driver is the default driver. If the Docker driver is not defined in the network definition, it's defined as a bridge driver. Bridge networks apply to containers running on the same Docker daemon host. In this way, containers in that network can talk to each other internally. Bridge driver has local scope. That's why we usually use it for single host. Because thanks to the bridge network, service discovery is automatically made for the containers included in this network. In other words, services know each other and can communicate with each other. This means it provides automatic DNS resolution between containers. Since the bridge network provides automatic IP address, the IPs are assigned to the containers and they are connected to the network. We do not need to make any extra configuration. Docker already configures this in the background. When we add a new container to the network, the IP address will be assigned to it and included in this network. Here we can also create restrictions for security. In other words, it is like two containers not reaching each other. When defining the bridge network, is it necessary to assign it automatically? No, there is no need. If we want, we can also assign subnets or IPs for the containers. When 1000 or more containers connect to a single network, the bridge network becomes unstable and can break communication between containers. So please take note of this. For a better visual understanding, we can draw the bridge network with the containers. Let's imagine we have one backend and one front-end services. We also have a database service that is used by backend. Let's run these as containers. We have three services now. Additionally, assume that we have services running on other containers. However, we do not want these three services to communicate with them. So, actually, we need network isolation. This is exactly what we need. Now, I will create a bridge network driver called myNetwork-bridge. Then include these three services into this network. As you can see on the screen, the bridge network automatically assigns them IP addresses. These services on the same network can communicate with each other. The containers that are not part of this network do not have direct access to these services. This way, we provided network isolation for these services. If you want, you can define multiple bridge networks for a service. For example, let's change our previous three services to improve the architecture. In an ideal scenario, we would not want our front-end applications to have direct access to database servers. A user submits a request through the front-end application. This request goes to the backend APIs. And these APIs get the responses from the database servers and send them back to the front end. So, we have the following situations. The first one is that database and backend should communicate with each other. The second, backend and front end should communicate with each other. The third one, front end and database cannot communicate with each other. In order to create a new network based on this ideal scenario, I need a few things. After creating a bridge network, I will add the database and backend to this network. This means that the first requirement is done. The database and backend communicate with each other. Secondly, I will define a new bridge network. I will add front-end and backend to this network. In this way, the second requirement is done. Front-end and back-end communicate with each other. You can also see the IP addresses of the containers that are connected to these networks. As you can see from the screen, the communication between front-end and database is not direct. They are isolated by these two networks. Why do we need this? When there is a security vulnerability, the request from the front-end is sent to the back-end, preventing someone from directly accessing the database server using the front-end service. Now let's focus our commands. When creating a user-defined bridge network, we use Docker network create -n bridge and bridge network name. To connect a running container to an existing user-defined bridge, we use Docker network connect, network name, and container name. To disconnect a running container from a user-defined bridge, we use Docker network disconnect, network name, and container name. When we create a new container with network configuration, we use --network flex. When we create a network, Docker engine creates a non-overlapping subnetwork for the network by default. If you want to override this default and specify subnetwork values directly using the --subnet option. Additionally, you also specify the --gateway, --IP-range, and --aux-address options as you see on the screen. You can check this page for more. Now, let's use the previous architecture into practice. We have backend, database, and front-end applications. We will run them as containers. First, let's create a bridge network for the database and backend. Docker network create --driver bridge back-network. When we look at the network with this command, we see that back network has been created. Now let's create other network definition for the backend and frontend. Docker network create --driver bridge front-network. We can see that front network has been created. Let's look at what IP ranges these networks have. For that, we use Docker network inspect command. For the --network, we see 172.19.0.0. For front-network, we see 172.20.0.0. Now, we will create a container for the database with MySQL Docker image. For the backend, we will use Redis Docker image. As you can see, in this command, we are able to define more than one network definitions with --network flex. We can use Nginx Docker image for the frontend. Let's look at these three containers using Docker ps command. All three are running. Let's also check their IP addresses. To do this, we run docker inspect command for each container. We can see that it uses the first IP address from the backdash network range for the database, because the gateway address uses the value 0, 1. When we look at backend container, it's connected to two networks. We can see that it comes from backdash network and it comes from front dash network. For the front-end container, it displays IP address from the front dash network. It's time to check the communication between these containers. First, I will connect to the backend container. I will try to ping the database and front-end containers from the backend. Ping command not found. Let's install the package for the ping command. Now I will ping again. Ping database. As you can see, it can ping. Let's do this for the front end. As you can see, it is also successful. Let's exit the backend container and try to ping the database container from the front end. Here, we expect them not to be able to ping because they are in two different networks. Let's connect front end. As you can see, the output we get shows that there is actually no communication because they are in different networks. The database name not resolved. Conversely, if we try to ping the backend, we can successfully ping the backend container because they use the same network, front dash network. Now we provided network isolation between our applications in this way. Here, I would like to show one thing. I will add backdash network to the front-end container to understand the example better. Let's check the IP address of the front-end container again. We see that IP address has been added from the backdash network. If we run disconnect backdash network command for this container, you will see the first IP is removed. Now let's connect to the front-end container again and check that we can ping the database container successfully. We can now communicate with the database service. As a result, bridge network uses a software bridge which lets containers connected to the same bridge network communicate, while providing isolation from containers that aren't connected to that bridge network.